This is the 4.1 through 4.3 test review, problem number 4. It says if f of x is equal to 2 cos x plus sine squared x on the interval negative pi to 2 pi, use calculus 2. Letter A, find the intervals in which f is increasing or decreasing, and then letter B, which follows from letter A, find the local maximum and minimum values of f. So obviously our first job here is going to be to find the first derivative of our function. So f prime of x is going to be equal to, the derivative of cosine is negative sine. So negative times the 2 will give us a negative 2 sine x for the derivative of our first term. And then keep in mind that sine squared x is really sine x quantity squared. So when we differentiate that, that requires us to use the chain rule. So we would bring down the 2 first, so plus 2. We would differentiate the outer at the inner, so we would have the sine x still. But then we have to multiply by the derivative of sine x, which is cosine x. All right, and then we can simplify this a little bit. We can factor out and I'm actually going to factor out because this is all one term here, and this is one term. So I am going to factor out a negative 2 sine x as a GCF. So then my first term is just going to be a 1, and then my second term is going to be minus cosine x. And now the question that I have to answer to find my critical values is, where is this equation equal to 0? And since I factored it now, basically I'm just looking for where is negative 2 sine x equal to 0, and where is 1 minus cosine x equal to 0. All right, well, if I divide by negative 2, I still have 0, right? So this is just going to be, where is sine x equal to 0? So if we think about our unit circle, sine is the y value of the ordered pairs. So sine is 0 at pi, right? And at 2 pi, also at 0 and at negative pi. Because remember, our interval here is from negative pi to 2 pi. So we could draw a picture of this, but basically we have to consider ourselves as though we are going 1.5 trips around the unit circle, right? Because negative pi technically would be right here, right? But then we'd be moving in this direction and we'd be going back to 0, and then we'd be going to pi, and then we'd be going to 2 pi. So our window that we're looking at for this problem is 1.5 times around the unit circle. So in that window, all of the locations where sine of x is equal to 0 are going to be at, so let's write this down, critical values are going to be at x equals negative pi, 0 pi, positive pi, and 2 pi, because sine is 0 here and here on the unit circle, right? And then the second equation, if I add cosine x to the other side, then this becomes 1 equals cosine x. So now the question is, well, where does cosine x equal 1 on the unit circle? That only happens at one location, which is that spot right there, right? That's where cosine is equal to positive 1. So in terms of our window, it's going to happen at 0 pi and again at 2 pi. So our critical values here are going to be 0 and 2 pi. All right, so we do have some repeating between the two. That's fine. So our next step then is going to be to build our number line with our critical values on it and do our sign testing. So I am going to draw my number line here. And the critical values for this function, I'm going to put them in order from left to right, are going to be negative pi, 0, pi, and 2 pi. And technically, we could put our other endpoint on there, or our endpoints are negative pi and 2 pi, right? Those are the endpoints of our interval. So we really only have to test those 3 intervals in between. And again, we can choose any values that we want to choose for our sign testing. And we don't really care the value that the function gives us when we plug it in. We just care about the sign, right? So between negative pi and 0, I might choose, since I'm just dealing with sines and cosines, an easy point would be negative pi over 2 for my sign testing. An easy point between 0 and pi would be positive pi over 2. And then an easy point between pi and 2 pi would be positive 3 pi over 2, right? So when we think about that, those locations are going to be here and here. And whether we're talking about negative pi over 2 or whether we're talking about positive 3 pi over 2, the location is the same on the unit circle and the ordered pair is the same on the unit circle. And that ordered pair is 0, negative 1 here, and it's 0, positive 1 here, right? So when we plug these into and we're plugging them into our first derivative right here to test for the sign that we get, right? Whether it's positive or negative. So if I'm starting with negative pi over 2, the sign of negative pi over 2 is going to be negative 1. So I end up with negative 2, which is negative, times negative 1, which is negative. And then I have 1 minus the cosine of negative pi over 2. Well, the cosine of negative pi over 2 is 0. 1 minus 0 is 1. So that ends up being times positive 1. Well, negative times positive, that makes this region right here positive. Sorry. All right. Next, we're going to test positive pi over 2. Right? And so when we test positive pi over 2, the sign of pi over 2 is positive 1. So I end up with negative 2 times positive 1. And then finally, cosine of pi over 2 is 0, and 1 minus 0 is positive 1. Well, a negative times a positive, that's going to be negative. And then finally, 3 pi over 2 is our last test point. So when I check that, the sign of 3 pi over 2, once again, is negative 1. So I end up with the negative 2 times the negative 1, and then 1 minus the cosine of 3 pi over 2 is just going to be 1 minus 0 again, which is times a positive, and then 2 negatives times a positive are going to make this region positive. Okay, so I am able to now say where f of x is increasing and where f of x is decreasing. So I can say f of x is increasing on negative pi to 0, and I'm going to use a round bracket on negative pi, or excuse me, a square bracket on negative pi, a round bracket on 0. Union, it is also increasing from pi to 2 pi. And then f of x is decreasing in the middle there, so on the interval from 0 to pi. So this is the answer to part A. Then part B asks us to find the local maximum and minimum values of f. Well, since we're switching from increasing to decreasing to increasing, that means that those critical values that I found in part A, those are my maximums and or my minimums, right? So that is going to happen at 0 and at pi. So f of 0 and f of pi are the two values that I need to find. And when I plug pi in, again, I'm plugging it into f of x. When I plug pi in, cosine of pi, okay, that ordered pair here is negative 1 comma 0, and cosine is negative 1. So cosine of pi is negative 1, 2 times negative 1, right? And then I have to take the sine of pi, which the sine of pi is 0, and I have to square it. So this gives me a value of negative 2. Then I'm going to check f of 0. Sorry, I don't know why I didn't do that one first. Doesn't really matter. So I end up with, once again, my 2 times cosine of 0. Well, cosine of 0, remember 0 is the start of the unit circle, so that's 1 comma 0. Cosine is 1, so I end up with 2 times positive 1 plus, and then once again, sign of the ordered pair at 0 pi is 0, so 0 squared is still going to be 0. This gives me a value of positive 2. So obviously I have a local maximum at 0, and I have a local minimum at pi. So this is my local max, and this is my local min. Okay.